Reload. Right. Yes. Hang on. Let me check if it's. Yep. I think it's quite readable. Yeah, okay. So yesterday, while I was doing something else, what was it? Something to do with trees. For totally different thing. Totally. I had the same problem. Well, basically, I had a segmentation fault. And I realized what was causing it. It's a dangling pointer. I've never come across it because I program in Go. The garbage collector takes care of this for me. Excuse me. Yeah, so the garbage collector is usually taking care of this for me. I kind of thought that might have been the case yesterday. But yeah, having that problem twice on the same day sort of helped me out. Or sort of helped me make better sense of what's going on. So right, so what I got to do is this here. The value is getting freed. Or it's not available outside of the scope. One of those two. I'm gonna ask Cloud. Oops. Option instructions. The value is a slice of U8. Becomes a dangling pointer. And it gets added to the frame. How can I fix this? Clone the instruction. I was thinking of this yesterday to pass the whole. It's a bit quiet. Too quiet. To pass the whole object. I don't know how. Why would this solve it? Why would option 2 work? Won't it lead to the same problem? Right. If the object has longer lifetime, and I think it does. I do like that better. Might have to modify this. I think this one's not necessary. So we're gonna modify this to accept instructions object dot function instructions. That should cause a problem. Then program instructions is equal to, and here there's no problem of a dangling pointer because instructions are already allocated, is my understanding. It's not fully complete yet. Okay, that didn't fix anything. Actually, this kind of looks correct. Constant and return. Yeah. Return opcode. It's about 20. No, 22. Yeah. So why? So this might be something else. 757. Is it just the formatter that doesn't work? Just get rid of this for now. Invalid enum value. $75. So that actually looks right. What is it? The second one? That's failure. Might be. Just try the first one. Weird. Instructions are correct. I think I might need the debugger. I print. The weird thing is that is correct. It's the right set of instructions. Is there another print statement? Oh, that's the only one. It's like a different letter every time. Invalid enum value. Oh, do I increment? Frame index. Self-dot frame index plus equals 1. Sounds correct. Oh, let me check the instruction pointer. Okay, there we go. That's why. Causing it's probably an integer overflow. Instruction pointer. It's an I64 and cast. I want to print the value before frame.ip. And it's less than, yeah, it's less than self-dot current frame dot instructions dot len. At least the assertion should fail. Hang on. Oops, not that one. Of dot frame index. Right. It's as soon as it switches to the next frame. The instruction pointer goes all wacko. Up call. Hmm. Okay, I think I need the debugger. Let's add one. Yeah. Oh. Maybe that one. How do I GD? I don't know if that's the problem. New frame. Okay. So that was it. Because the whole time I was thinking I was saving the frame, but it was only a pointer to the frame. What I wouldn't know is if this was just a reference to frame, then if I remove that, okay, hang on, let me save this first. Get rid of that. Okay. Function execution works. What I want to know is if, let's say, this was not a pointer, but rather a frame. That then new frame. Does still work? I can fix that. 299. But I do need the pointer here. But maybe okay, so that will work too. Yep. I mean, that works because I want to check, don't need VS Code. If, yep, it works as far as I understand. Because as soon as we say it's a frame, that many, like an array of frame, not a slice, like array number of frames, is allocated onto the stack. Not allocated, like it uses the stack. Not, maybe not. It could be allocated when the virtual machine is allocated. Because instead of now allocating pointer to frame sizes, it would allocate the entire frame. I think it might be better. Let's say if I wanted to optimize it later, I could only allocate a frame when it's needed. I think they both work. But with this one, there might be how many frames? Yeah, I mean, it's 1,000 frames. Maybe not necessary. Stack size is fine because it doesn't make any sense to like allocate each time. It's better to allocate. Yeah. This one, not sure. I think I'll leave it as is. It was quite interesting though. Okay. Damn, that's pretty cool. Now I can execute functions without arguments. Okay. So I guess I've done quite a few stuff. Yep. Oh, this is a good test. One. Yeah, let's try this. Expected value is 3. Excuse me. It's 1, B is 2, C is 3. Okay. I'll add this one too. This is a pretty good test. I guess the second one doesn't work either. Okay, it's just this one. I know why that doesn't work. Because I don't have implicit returns. It's a syntax error. Oh, motherfucker. Hang on. How does this work then? Technically, that shouldn't work. Oh, so it was that one that was failing. Nice. Okay. Let's go. Yep, that's a good test too. Yeah, that should work. That should work. Expected tonight. Okay. Let's go. First try. Nice. I'm quite proud of that. Pretty cool. Test functions without return value. Interesting. I like to see what would happen as is. Excuse me. Damn. Whew. Might be the AC. I don't know. I'll just leave a weird. I'll just leave 99 for now. Found 0. Okay. But why 0? I see. I think there's some... I don't know. I don't know about this one. When does the frame get... If there's no return... That is actually a good point. Op return. So the frame only gets removed if a return is called. Yeah. That's incorrect. Compiler. Function literal. Yeah. Might have to even check the parser. Yeah. Function literal. Excuse me. And I'll be right back. Okay. I had to clear my nose. There's no return statement. The function. Yeah, exactly. I don't like the implicit return. Excuse me. But I think if it's void, like if it returns nothing, it doesn't need to have a return statement. Return. Compiling literals. Yeah, here. Like to check. No, skip. Compiling. No. Oh yeah, actually. Compile function into a series of instructions. Hey Brian, how you doing? Excuse me. Yeah, I'm good too. Thank you for asking. I would say quite far. I just finished, kind of, not finished completely, executing functions. So for instance, all of these work. So yeah, so takes an input, creates an AST, parses it, and then compiles, and then sends it to the virtual machine for execution. And currently I'm trying to fix this. Oops. What's the virtual machine for? I mean, it's the virtual machine is Zig, basically. It's a fancy word for a virtual machine, really. It's not really. So I use Zig as the CPU, so that it can just handle all the low-level stuff, and I can just send it bytecode. If that makes sense. And I also, hang on, maybe I can show it. Yeah, and I also keep track of the stack. So I've got like a basic memory, and the CPU is Zig. Zig, the language itself. So that way it can just run everywhere, and I don't need to worry about that bit. Abstract interpretation. Do you mean abstract syntax tree? Abstract interpretation, not really. No, in that case, I don't know what that is. Why'd you ask? Yeah, I am. I can't read your name. I am from India. Usually you use something similar to what you did, but you input ranges instead of constants, and it allows you to calculate the lower and upper bound of functions to see statically where you need to do range checks and where they're not necessary. Hang on, I gotta read that again. But input ranges instead of constants, and it allows you to calculate lower and upper bound of functions to see statically where you need to do range checks and where they're not necessary. I'm not sure I understand that, Brian. Are you in India or some other country? No, I'm not in India right now. Calculate the lower and upper bound. What do you mean by range checks? Yeah, not sure I understand that. Why am I making the compiler? Out of curiosity, really. Just for fun. No other reason. Minimum and maximum values for each parameter of a function. So if you pass an index, you can know the maximum value the index could have there. If I could still know that, is it big? Hang on, VM. Because each of these objects has an underlying type. Excuse me. I think that would be guaranteed by SIG, no? Because each of these objects has an underlying type, which is, I think integer is just an I64. So I don't know if that's strictly necessary. Unless the function has one caller where the check is not done, because when you combine ranges of each function, the less strict the range, strict range will expand the input range, making it possibly unsafe. Like two callers and the second caller did not do the check. Okay. If I understand correctly, you mean, let's say there's two functions and one of the functions sort of overextending the memory it has access to. That's a good question, really. I haven't done function parameters yet. I think how well, I guess I would just create a new scope, because right now I don't have parameters. Well, I can't execute parameters. Better to restrict your ranges as much as possible early on, because then all your call functions will have a strict range, but it also means you have less flexibility because each caller must do a check before calling function with strict parameter ranges. Yeah, I'll keep that in mind, because that's the next thing I've got to do. Is, what's the word? Compile function parameters or arguments. Because right now, if you notice, geez, why does it go all the way up? See, hey. Yeah, if you notice, none of these tests take in arguments, because as is. Haven't really compiled arguments or executed them for that matter. That is the next step. Hey Anoxidus, do you have a symbol table? Yes, I think I do, but whoa, it's caps lock, yeah, figured. It's not caps lock. Okay, sorry. Yeah, I do have a symbol table. Where's my compile? Where did it go? Or maybe hang on. I thought I did. Oh yeah, I do. But I only use it for compiling the input. There's no scope in the virtual machine. As of right now. What is the definition of a symbol? What is the definition of a symbol? Hang on, I gotta check. Do you track the sign and size? I just use... No, I don't think so. That's a good question. I do. No. Hang on. I do. Because... Okay. I think now I understand your question better. So each instruction... No, that's the instruction. To be fair, I don't even think I used the symbol table. How do you know your own compiler works? I don't know, I write tests. When the tests pass, I consider it as working. You track sign and size. That's a good question, Brian. I can't remember. When did I start? Maybe 2 months ago? Maybe. Or 3. April, May, June. Yeah, no, 3 months. You'll notice there's a lot of... I also intentionally skipped a few of them. Mainly because I thought that I can do this. I can just do it later. To keep it simple for right now. You'll notice there's a lot of to-dos all over the place. Yeah, I mean, I think I've forgotten quite a lot of details. When did you learn programming in general? I'd say maybe. Well, that's a difficult question because I went to college like 10 years ago, maybe a little more. No, 15 years ago for computer science, but I didn't pay much attention. So I actually learned programming 5 years ago. Okay, what do I do? Program slice. I've heard of slice, never heard of program slice. Not sure how to handle implicit return. I say I did a program slice to track variable xdcat, and I wanted to online run the code necessary to make that, think that the whole program was working. How would you know statically what is the execution space that is possible to remove from the original program? Keep xdcat as flexible as the original range of xdcat. Honestly, I don't know. Not sure I understand the question. It's possible to remove the original program to keep. Program slice means just taking one part of a program, but doing so in a way that does not change the meaning or correctness of it. Do you mean the program that would eventually be compiled? I'm guessing yes. But I do understand the point of it though. Before compilation or after? You mean to say if like individual statements would stay correct? Good point. Let me think. As is, it will work because I just use a global scope. So you could pull out any statement and technically it would just work. But that's just, but like if you put it back together, I don't know if that would work. I think in isolation, things would work right now. Because I think that's what the tests are anyways. They're all testing parts of the code in isolation. If I understand you correctly. Implicit return. Okay, I think I gotta check the parser. Parse function literal. Parse block, but these also handle if statements. Check if there is a return statement. If not, implicitly return. I think this could be a problem for future me. Or maybe in the compiler. Function literal. I mean, it could be a problem for future me. Let me check the book. Function. What if there is no return statement? Instructions. Okay. Yeah. I see. So you can just handle it in the compiler. Yeah, I could do that. And that's in function literal. Yep. Hang on. We won't first check whether we need to replace the pop instruction with an op return. Right. Okay. That's a good point. Either because it was already an explicit return statement or because we now changed it. Actually, we might need to and I guess I just need to check if the last instruction is a pop instruction. If it is, no, I think this could be simpler. Is a return. If not, add one. Don't need to check for anything else. return statement. From first principles, you have to include anything that XDCAT depends on. That means any variable involved in an operation that leads to an assignment to that. Then do that for each variable involved. You can imagine a program that renders a sound wave. We sliced the audio magnitude value. We could remove all the visual effects since they depend on the magnitude. But the magnitude does not depend on the waves. It's like the magnitude happens before the effects in call graph. Okay. I don't know, Brian. I haven't thought of it that seriously, if I'm honest. But let me try and understand what you're trying to say. Any variable involved in an operation that leads if the program loop can be visualized as a flow of data from top to bottom, anything past your variable calculation can be removed. Yeah, I think so. Unless, yeah, I mean, because a variable would stay on the stack till its last reference point, after which it would get popped off. I think that's kind of implicit with the stack as is, if I understand you correctly. Yeah. What happens when I come across op return? Null return, not sure, something like that. I think I understand what I need to do here. I go to function literal. I can check the last instruction. Maybe I can do it before I exit the scope. Last instruction. Yeah, that. Function literal. Here. Not equal to opcode dot op return can I add, there we go. Maybe there's a program that can't be sliced much because everything it computes is involved in the process of calculating a final value. Say over that value might be able to remove. Okay, but what are you trying to say? I kind of get all of that somewhat. Fair enough. Yeah, because I'm getting a bit confused. I think I'm lacking context, but it's fine. You can think out loud. I don't mind. Add last instruction. Opcode and position. Hang on. No. There. Add instruction. Remove. Let's remove, replace. Okay. Add instruction. Compiler, take index. Yep. Mark A. Hang on, why am I making... Yeah, don't need this. Hang on. Just opcode operands. Yeah. Soft dot emit opcode dot return, and then takes fuck, but there is a problem. What if there is a return already? Actually, that doesn't matter. Yep. Okay, there we go. What's that? Attempt to use null value. Actually, it should add a return in both cases. If there are no instructions, and if the last one's not a return. Gotta recheck the book. The video. And all of this is done. It went too far. Uh, that requires changing the previous locations in which. Okay. I don't care about that. I'll just leave it as is. Can now change the case where ast.function literal branch in the compile method to use the last instruction is. Replace last pop with return. What if there is no pop and no return? I see why I added both. You want to emit return. Yeah. Actually, I don't care about this. This is so that it implicitly returns. All I want to check if the last instruction is not a return, I want to emit a return. At least that's what I'm trying to do. What's the problem there? Attempt to use null value. If self dot scope self dot scope index dot last instruction last instruction if last instruction dot opcode not equal to return then get rid of this. See if that compiles. Assertion failure. In the VM 288. Yep, it's the the rest should still work. Motherfucker. What? Which line was it again? 288. Leave that in. Function instruction. But actually it won't be a function instruction. Now will it? Right, I know why. It's this method, right? This one right here. Oof. There could be like so many things going wrong. Check if return exists already. $288. It's the same place. To be fair, this should be a function instruction. I think this is just the same. Does it say which test? Why is it not a function instruction? If li dot opcode not equal to Okay, that's fine. It's just the assertion here. Up, return. Should return null, really. So at this instance, huh, there is I don't know if adding 0 makes sense. I mean, the test will pass, but let's say which one? 1027. Oh, in the compiler. Right. There's going to be an extra return. Why? Not that one. Not that either. Yep, that's wrong. I should just be at a turn. If I go up. If li dot opcode is equal to code dot op self dot remove last instruction. That's probably better. handles cases where either function body is empty or there are no return statements, but there is op return. I gotta fix this to do there is a bug. This could be incorrect when, let me see if there's a test case. That could help highlight this. Early exit. This should be fine, really. Yeah. In function calls with no return. Excuse me. Hang on, what am I doing? Yeah. This should be no. Okay, perfect. I think that's fine. I'll return. This is check failing function test case. Ability. There is nothing to pop except function instruction. I wonder how the assertion didn't fail. Anyway, I think that's a problem for tomorrow. I'm gonna call it today there. Function calls made progress. What the fuck? Okay, I think I'll figure that out tomorrow. This could be done better. Also for tomorrow. Okay. Excuse me. Thank you for hanging out, as always. and shall see you tomorrow. It was quite, I mean, it was a bit annoying, but it was quite fun. I'm talking about the empty functions. It's a lot harder than I thought it'd be. Guess that's why compilers are hard. It's all the edge cases. If I were to only do the, what's it called? What are they called? Like correct parts. This would be a lot more easier. Okay, that's part of it. Alright, thank you. And thanks again for hanging out. I'll see you back